How's it going, everyone? Welcome, Julián Gonzalez. And today, let's take a look now at the digging to the roots of JavaScript as a way to now understand is the low-level features that JavaScript virtually does anytime that we write code. So the idea is to get the feeling of how JavaScript works and the ebbs and flows. So, so far in chapters 1 and 2, we briefly describe is based on these books. You don't know GS. So we briefly describe is these two chapters here. So the chapter 1 we went through describing is what is JavaScript, who made that, who now owns that, whether it's a legal trademark or now who oversees the technical specifications, who are those peoples, where are the name from, what are the roles, what are the goal, and also because we can now run JavaScript in any different environments, and each environment has or expose certain features that we can operate on that. So despite that all of these different environments, whether it's a browser, the server, light bulbs, or robots, you name it, the reality that matter is the web. And because now here on the web platform we have is the JavaScript console, all right, where this will allow us to say, hey, we can now run is JavaScript files. This in fact is not a truly JavaScript environment. So we have things like the console, by the way, and since this console is just a JavaScript friendly environment, and we also show some of couple examples of that. We also look that when it comes to provide is the or follow the motto of the TC39, which is the commit that oversees the technical aspect of this, which is don't break the web. This is why we look at things like polyfills as a way to provide now functionality to the language and guarantee the backward compatibility across different browsers, older versions. So now your applications can run as expected. So because here in JavaScript we can look and we also saw how can we apply its different approach to solve different problems, such as the uh, functional programming, object programming, and procedures. And when it comes to understand now how to write your code in order to make sense of what the JavaScript engine is doing, the TLDR is that the JavaScript engine at the end of the day is just is a compile language, and it boils down to how it manages now errors, which is something that compiler language actually have this particular phase. So because of that, and since the this idea that JavaScript is not performant, whether it's because it now have a parsing and an execution phase. So ASM was a subset of JavaScript that now pour is an Unreal game engine into the web, which set a precedent that JavaScript is fast enough to actually run this kind of games or heavy CPU intense, GPU intense task by providing a certain hints to the JavaScript engines to do some optimizations. So years by, and the WebAssembly, which is now the spiritual successor of the ASM, say, hey, we're going to take things forward by saying, I want to now put this stuff, in this case, the parsing out of the way, and by having this the intermediary representation of the language, similar as an assembly, like now we can is use this as a universal target compiler. So no matter which language you have wrote that application, we can now target that to output is WebAssembly code that can be now run in assembly environments. So this is the idea of pushing all of this and why it is quite important for us to do that. All right. And also is to talk about uh, the strict mode, which is another part of what it is JavaScript right now, which is just a set of guidelines to do things the best way. So now JavaScript developers write code that has a good chance for the JavaScript engines of of, of running your code and get optimizations of that. So, but the point is that this is strict mode, which is this set of guidelines that tells developer what are the best things to do so that the JavaScript engine has a better chance of optimizing and running your code, right? It is something that despite that we have the dev tools in JavaScript code as it is, most of the time those particularly things are not are not JavaScript spec compliant. So, but even though the idea here that using a strict mode is this. Again, in chapter 2, we're now serving JavaScript, particularly serving our knowledge in JavaScript, I will say, about now how JavaScript see each file as a program, as an independent program, and when you want to make JavaScript see all of these different standalone files to act as a single program, is by sharing its state at runtimes or by sharing its public API. And in the case of the EX6, is when you have now all of this linking by importing a particular JavaScript files and do that and so on and so forth. This particular in single files, all of them become interoperable at runtimes, aka making them to all now collaborate and act as a single program. But the thing here is that JavaScript, it is good for us to think that, or it's great for us to see that JavaScript see this particular file as a single standalone. So you can treat your files as it is. So we also look at what a program is, what are the things that we can do in a program, what is a value, which is what it represents, what is the main goal of the values in a program, which is to manage is the state in that program and how you can represent that you have now a string number that each one of them follow is particularly spec. String follow is the Unicode, whereas the number follow is the IEEE 754. Then you have booleans, you have now symbols, you have big int, you have this kind of emptiness like null and undefined, and also we have is objects. And how now object we have is object per se, similar like a spreadsheet. What you can have is the identifier column followed by the value, and this value can be whether of any of these primitives that I mentioned before, an array, or even a function, right? So functions is also a value, and when it comes to now, we also look at how can we is describe values in the language as a literal or held that inside of a container. How can we use variables? How can we define variables? The different syntax form that variable has. So for example, like let, const, var, let, and const, and what are they doing in each specific case. The other place where we can define values is in a functions declaration, when the association between the identifier and the value happens is at parse time, and also is uh, the idea, or my bad, is the other places where we can define is variables, such as inside of a function body, right, as a parameter, and in a try catch block. So also, when it comes to understand that how can we use values, what are the roles that values are playing in JavaScript, whether it's a procedure or a mathematical definition of a function, right? So in these two aspects, things are very strict, so they particularly follow that guidelines. And when it comes to define a function or to use a function as a value, it has now specific ways to do that, whether it's functions definitions or function expressions. And now we understand is what is the subtle difference between a definition and now a value. And when you assign when you assign a function value to a variable, so when that happen, when that evaluation happen, and talking about is now assignment or passing a value, because in other language we also look at how that thing is managed and how that thing is managed here in JavaScript. All right, so primitives now are copying values, whereas the objects values are now passed or assigned by reference. And all of this is just to understand that the idea about the functions, how can we use now functions definition and function expressions, and how can we use functions as part of the value in an object. So enabling now is how can we organize our code. But before going to that, we also look at with the comparisons, the equality, the type coercion, and when it comes to comparisons, how now the language, when they're trying to compare the same type, is gonna look at based on the values in it itself, the content in itself. However, if they are not the same type, then it's gonna try to coerce that value, especially the double equal, into something that they can now work on that, especially into a number, usually into a number. So because of that, right? So a good example of this is if you have now an object here and you try to coerce that to, let's say, a string, okay, something like this, it'll say that this is false because it is this. So it will try to now coerce this into a number, and when this is coerced to a number, it returns you this, not a number. And when you compare now this when you have now a number and a string, okay, it will coerce that string into a number, right, which is 0, and now this is the end result of all of this. So this particularly double equal has a preference to coerce all of the values into a number, right? And when it comes to compare these values, all right, yeah, when it comes to compare these values here, how now can we, okay, so when it comes to compare these values, exactly, so when it comes to compare these values, how this comparison, if they are the same type, is made through a referential value referential. So in other words, so the comparison here is a referential identity. So if are the same identity, and in the case of objects, because you, especially here, you are creating is now two objects here, this will evaluate is to false. And similar for functions as it is. Alright? Because what you're doing is now is this particular function, because at the end of the day they are being created functions, objects, an array in this case. So since they are now created, and remember that their values, if you pass that or assign to a variable, they are passed by reference, which means that if you have now several reference or several variables that hold that reference, good, they are the same. But if not, so they are not the same. And this is quite interesting because if you do things like this, all right, so for example, you have now variables like this, let say object 1, and here you have now a name. To be more explicit, we're gonna put it here as a user 0, because we are programmers and we started to count from that. So there, then you say, hey, what'll be is the address, you know? Well, your address is something like this. You have a zip code, right? So whatever zip code it is, you have now a street. You say close to your heart, okay, and there you go. So this is good for user 1. So let's say, hey, let me now is health is another reference, okay, here, and you got now the user 0 reference. You have now the user 2 reference, okay, and you have also the user, let's say user 3 reference, right? But in this case, we're gonna do in this particular way, right? Remember that at the end of the day, all of them, unexpected syntax error, unexpected string, in which line? Line 1. Let user address zip code. Oh. Syntax unexpected string. We got this, name, address, zip code, unexpected string. close to your heart. It might be this. Oh, of course. Silly me. Yeah, there was a mistake. Okay, you're right. You're right. You're right, JavaScript. You're right. So there you got it. Okay. So if for some reason if for some reason we change the reference by saying it's like, hey, user zero. Now the name is, well, Arturo. So because all of this has nested reference to that particular object, user 3 will have now value updated too. So this is what happens when you have now all of this reference and you need to understand who is the true value, who is the identity here, right? And because in other languages this is not how it works, it turns out that this is how it works, right? So if for some reason now we along the reference change, we change the names, all of those other reference that are pointing to that is going to change that. So for example, if you have now user 2, let's say, hey, let me now is evaluating this and say, hey, this will be now Euler, right? So user 3 will have that now reference here. And this is when the nightmare begins, because if you have now multiple reference of one particular value, which is an object, okay, and if this object has all of these different reference, and some of them mutate this, and some of them mutate this another property, and some of them this one, so it turns out that it can become quite a nightmare because you don't have any native mechanism here in JavaScript so far that allow you to keep track is the state change. So with proxy, we already have the particular mechanism that allow us to do that. So this is just to describe is a comparison, and then it comes another section, which is the whole, how can we organize our code, all right? Whether it's a traditional way, as a classical model, whether it's a function, and then you export that function's return key as an object, okay? Or as a collection, all right? Or you can also is now uses the new EX6 to say, hey, let me import and export some of these particular parameters, right? And then also we look at the way of how can we now organize our code via classes, which is just a syntactic sugar that is behind the scene is using the prototype chain, which is something that we're gonna see that in today's video, as we now organize our code when the problem is cooperation and coordination, right? So when you have now different things that need to cooperate and to coordinate among themselves, that now is a good candidate to use object-oriented programming, like class. So here in this, in chapter 3, is just to dig into the roots of JavaScript to say, hey, let's actually take a deep look of this, which is how can we now, all right, how can we now exactly, it's like how can we now, in our case, all right, how can we now look at this specific stuff that's happening in the language that virtually affect every code that we write, okay? So in that sense, well, we first explore about the iterations and why iteration here matters. Is because most of our programs that we wrote, most of those programs, or most of the programs that we write, are built to process data, a large amount of data, huge, colossal amount of data, and later on uh, make decisions on that, right? And because the patterns, or yeah, exactly, because the pattern that we use to manage that volumes of data, it will highly impact on how we're going to do that. So if this is something that is not readable, it will, in fact, uh, impact how can we maintain that particular code. So this particular standard, all right, of how can we consume is this uh, series of data, okay, as an iterator pattern that describe is that how we're going to consume from a data source, regardless the data source it is a database, is a document, is a somebody that is even streaming data. Now, regardless the data source, we're going to consume that chunk one by one until there is no more. Now, so this pattern is something that has been around with us for decades, right? This is part of the behavioral design patterns, where the iterator is a way now, by having inside data structure this custom type that has a reference to the underlying data source, and expose now a method for us that makes us to call a functions that is gonna give us is the value and a boolean called done to verify if we reach the end of that collections or of that data source. All right. So this is pretty much like when you have in a database, you now query all of this, and if the data set is small, you can actually is take each one of those rows and assign to a variable, and you can do some requires transformations or computations on that. But if the data source is huge, it will give you now chunk of this data until there is no more. So this is exactly what happened here in the uh, in in the realm of the databases, or in the realm of JavaScript. So because now the way how we can consume those iterator is via the triple equal, the spread operator, or a specific syntax that is going to verify if that object that you provide now implement is this iterator protocol, okay, this contract. So it makes a lot of sense for those syntax like for off loop to actually verify if that now contain is this contract, this iterator contract. Good. Then I will now to call that behind the scenes. I will now to call that function method next until there is no more elements here. And not only that, I can also is iterate into async operations here. That's quite interesting, by the way. But it turns out that this is the way of how we can consume operate iterators, as well as the spread operator, which is going to evaluate if that is an assignment expression, this particular value here, okay? And if it is, and if that assignment expression or that expression produce now something that has an iterator protocol, this contract, all right, now it's going to call that method, all right, until there is no more elements, and then spread that into that. So this is, for example, when you have now an array, and for some reason you say, hey, I want you to now have and spread this array like this, right? This is pretty much what you are doing. So you say, hey, this expression is now, and this expression can be also is something like this. Make no mistake about it, right? All right. Intermediary value is not iterable. Interesting. But what if I want to return that? No? Can you not return that? No, but I want to return that. You know? Because if I do a thing, it's like you're gonna not. In theory, function expressions should be that as well. So if I say is now nums, okay, and then I say nums here, nums, and I call that function unexpected token. Really? But if I do this, exactly, it's an expected token. That's quite interesting. Remember, at the end of the day, this is how things work, right? If this expression that I'm evaluating is a narrow function or an assignment expression that is going to give me is now something, an object that has an iterate implement this protocol, then what it's gonna do behind the scene is now first is verify that you have that protocol, all right? And if it is, I'm gonna call all of those methods as it is. You can take that my word, but you can actually see that in the spec to get yourself familiar with what I'm talking to, okay, what I'm referring to, which is this, not at all, which is this express syntax, spread element, exactly. You can take also the runtime semantics, right? Runtime semantic array accumulation, and in this case is this one. So it's gonna say, hey, I want to check if that iterator continue, and if it is, so let me now call the iterator step value, okay, which is, hey, let me the iterator result step here, which is now calling to the next iterator method, all right, and this iterator next actually going to run this function that contains the value. Yeah, its value is not present, then let the result completion call is this. If a result is throw completion, then set the iterator record done to true and return the result, right? If result is not an object, then set the iterator record done to true and throw a type error. So, but the thing here is that here is telling you what's going on with this iterator next, an iterator step, okay? And this iterator step is say, hey, I'm gonna call this iterator next, which give me is the value, and then let the done be completion iterator, and if done is throw completion, that set the iterator record done to true and return done as it is. So, but all of this is this abstract operation, as I mentioned here, which are operations that are not accessible for the developers, is something that happens behind the scenes, all right? And it turns out that this is what this is doing, okay? So if result is not an object, then set the iterator record to done, and then you got it, right? So if there is no value present, there it is. But this actually is making sure, the iterator step is making sure that that particular value has the iterator implemented. and then it's gonna call that, all right. And if the next is done, return the next index. If it's not, well, I want you to create this. Okay, I want you to create now this particular data structure here, this create data property, okay, with the object, the property, and the value, which is something that is going to return, perform create data property or throw of the array to string and the next. And create that property is or throw is used to ensure that own property are defined for the array even if the standard built-in array prototype object has been modified in a manner that will be creation of the new owns property using set. So, but this is what the spread algorithm is doing, right? It's going to locate if this object has now that particular contract, and if it is, all right, now let me actually is call that. And this is for the syntax, whether it's the off and the spread, all right, for consuming iterables. And when it comes to look now at the iterables, which is this data source that we can now iterate over, all right, this iterables values in JavaScript are collections such as a string, array, map, sets, and others that allow us to do that. So the idea is to understand this particularly overview of the to understand and to understand is to describe is what this particular thing is doing, which is great, all right. And also, for example, in this piece of code and how the things actually is working, which I do find that is quite revealing here. So you create now an map, you're going to iterate through all of this, which is the way of how it's going to iterate when you pass now an iterable is that it's going to give you is the index and the value, all right. So you can now assign this as expected. So it is quite interesting because in this particular cases, now a closure, for example, if you now define is a for of loop with a let, and then you somehow is now pass a function to an event listener via the button that you want to iterate. So you are now effectively are creating is a closure. And a closure is one of the most pervasive programming functionality across many languages. Right? And it is important to understand that this is not magic. It's just, it also is a source of a lot of bugs. To say a closure is when a function remember and still have access to a variable from the outside scope in the inner scope, despite that that function is called in a different scope. So this jargon here is to describe what a closure is, and a closure especially exactly, and a closure that's right. So in a closure, okay, in a closure is anytime you define is a function, right? So a closure is when a functions remember and continue to access variables from outside scope even when the function is executing in a different scope. So in other words, here, all right, you are creating now a closure. So the function who is now creating is a closure of the variable from the outside scope in the inner, so it can have access later on. So message here in this case is creating now a closure. Another here is this. So here you are creating now a closure. So closures actually allow is a function to remember that variable and act like some sort of models and the model pattern. Like the model pattern. So not only this, but also is here as well. Remember, is in any function's definition. So here is creating now is a closure over this, and similar to these buttons, right? Because anytime and thanks to let the IDX and buttons now are passed to the so each iterations, okay, so each iteration of the for of thanks to the let we get a new fresh on each iteration. Exactly, each iteration get a new block scope. Okay, each iteration get a new block scope, aka local, thanks to let of the ID and the bottom here. And this is quite interesting to me that since each, okay, since in each iteration since on each iteration here for since on each iteration if you're using var, you say index since on each iteration equals 0 and then it must be less than 6 is I less or equal to 6, and then you have is I plus plus, right? So because var is a scope per function, in this case it's a scope globally, all right? It's a scope globally, so this will work. It will show you that as expected. Exactly. But if for some reason now you say, hey, I do want to is set timeout here, and I do understand this. Oh, completely, man. Oh, completely, man. Oh, completely, man. Oh, completely, man. Oh, complete. So if I say something like this, and then I want to have access to console log and run that as you think I'm expected, what happened here is that we are creating is now not only is a closure, if you do that in this way. So you're not only creating is a closure here of this variable, right? Uh, but because the way how these things will work, all right, on each iteration, it's going to now call these functions, all of these six several times, right? But by the time that exactly it's gonna return you is now 7 times, and that is because var, unlike let and const, are block scope. Exactly, it's because var are block scope, all right. So it's like var is function scope, okay. Despite that, here we are creating is now is a closure. In other words, is a function that is remember what that function have, what is the value of that function, even after it is executed later on in a different scope. So what happened here is that when we do this, var is globally and functionally scoped. So on each iteration, it's gonna call this and it's not going to pass is the value is. It's going to pass is a reference to this, you know. So var is going to pass now a reference in this case, and then we call this functions 6 times, 7 times here. It's gonna call this function 7 times, effectively scheduling all of this by the web platform into the callback here. So all of this now is queued into that. So by that time that pass, the 2 second, since we are passing now is a reference to this, and because this code is evaluating it synchronously, so by the time that that code is in, which is removed from the call stack, the value is now is 6. All right. Yeah, the value of this is 6. What the fuck is why is this? Exactly, because we're starting to count it from 0 up to 6. All right, which is 7. So the value. So in other words, the confusion here is because how this value is passing into this. First thing first, we are here describing is now an iteration protocol, right? So this is an iteration. So this iteration, because we're using is var, which is our globally or functional scope. In our case, it is globally scoped. This particular code is going to execute synchronously. So this code is gonna be created is gonna be now evaluated in the call stack synchronously, and it say, hey, I'm going to now on the 0 times is going to schedule these functions to the web API, and on the next iteration on 1 I'm going to schedule this iteration on the next time, and so on, so on, so forth. So I am scheduling all of these different tasks into the callback queue, and now that code is gone. It's forever lost. But the value here are passed not by value, are passed by reference here, as you can see here, right? This is now passed is by reference here in the case of var. So it means that once we do this, all right, because the value are passing is by reference, and the final value that I has when the last evaluation happened was 6, okay. Uh, Therefore, now this is going to be passed down to this, all right. And to me, that's quite interesting. Why it go to, if I say 1 to this? Oh, is the number of time it evaluated. Exactly. No, exactly. It's because it's including is 6 and a little bit more. Exactly. Exactly, because it's including that. So the TLDR of this is that because this code is running synchronously, it said to JavaScript, hey, because var is now globally or functionally a scope, when you want to evaluate the first time, which is 0, I'm going to now schedule, I'm going to call this API and I'm going to schedule this function here. But this value that I'm passing here is passing as a reference via the scope. That's what happened. That's what happened. But it's this is via the closure here. And it's the closure that is doing it is magic here. So it is safe to say that based on the following code, since var is globally or functionally scope, on each iteration we want to, on each iteration we are calling or we are scheduling a function, we are scheduling a function that is that makes a lot of sense, that their value, that it is value I is pass or is whole, all right, is whole or is pass as a reference via the closure, okay. Because exactly, is passed as a reference via the closures, since the for loop evaluates the code synchronously, okay. Since the for loop evaluates the code synchronously, all right. Exactly. Since the for loop evaluates the code synchronously, when the exactly, so when the value so when the value since the for loop evaluates the code synchronously, the value of I at the end is 7, right? Because it goes from 0 and then evaluate 6. 6 is less or equal, which to me is quite interesting. And you say, hey, yes, 6 is equal, so let me actually go to the next one and when the value of I at the end is 7, all right, that value is what is being passed as a reference. Exactly. So the value, exactly. So since var is globally and functionally scoped, and on each iteration here we are scheduling is a function that its value is passed as a reference via closure. Here, for loop evaluate the code synchronously. So the value of e at the end is 7. Okay, so the value of e at the end is 7. Okay, and once the code is executed, is removed from the call stack, and now if it's not, and now exactly, it's removed from the call stack. Exactly, and once the code is executed, it's removed from the call stack. The event loop will ask if there any micro task to be evaluated at that queue. In our case, we don't. The event loop ask again. Okay, the event loop ask again and say, the event loop ask again, but this time to the callback queue. Okay, exactly. The event loop is, but the event loop asks again, but this time to the callback queue. Is there any task here? It will continuously to ask these questions until 2 seconds has passed. The web platform, okay, 2 seconds has passed. The web platforms put those functions in the callback queue. So the web platform puts those functions in the callback queue. The event loop put those functions into the call stack, and now, except the event loop pulled the function in the call stack, the call stack evaluate or execute those functions, and since console log has have a reference, is not a copy, which is what happened here. Since console log has a reference to the value of I, all right, and since that value is 7, it will call this function 7 times with the value 7. But this is exactly what happened, and it is via the closure. And it is via the closures. Var is function scope, so there is only one I variable shared across all interactions. The loops run synchronously, and I ends up being 7 after completion. Set timeout callbacks are scheduled to run after 2 seconds, and each callback closures reference the same I value, but it's because of that. It's because now they have the same reference is to the I variable, but it's because of that. Minor corrections. Number of execution. The loop runs 7 times and you will see 7 log times, not because the value is 7, but because there are 7 scheduled callbacks. And the event loop mechanism, the event loop doesn't communicate continuously as about the microtask and the macrotask. Instead, it follows specific cycles. Execute all synchronous code for the loop completes I becomes 7. Process all macrotasks, none of these tasks. Execute one macrotask like the set timeout callback and repeat the cycle. So when callbacks are queued, the web API don't wait 2 seconds to put the web API don't wait 2 seconds to put functions in the callback. No. It's because it's not the web API. Oh, the web API don't wait 2 seconds to put function in the callback queue. They start their 2-second timers immediately when set timeout is called. They add the callbacks to the queue when each time expires. They add the callbacks to the queue when the timer expires. Okay. But again, it's because of the closure. But again, it's because of the closure. It is because of the closure. And because we are passing, because closure holds that as a reference in our function or global scope, you are passing is a reference. Whereas now in let, anytime you now pass the reference, so you are create so you create a new fresh block scope. It creates a new because there are lexical scope. So what it's doing is, so you are now on each iteration we're creating this a reference. Oh my god. So on each iteration you are creating is now a variable, a block scope variable, a block scope variable, a block scope. On each iteration you are creating is a block scope variable. But on each iteration you are creating is a block scope variable into that. Okay, okay, okay. So, so, so what happened here is that here we are only passing inside reference. It is so it is so it is like saying so it is like saying um, while mm-hmm, mm-hmm, is like let I let I zero, and you're going to now run this code. Let I one, and then this go. When you use the let in the for loop, JavaScript essentially creates a new binding. And the association between the identifier and the value, what happens is that it creates a new binding of I for each iteration. So your mental model is spot on. So it's like doing is this versus the var versions where there is only one variable here, all right, which means is that all reference the same e, one shared variable. E is now 7, so all callbacks logs 7. So it's because now for of loops here, thanks to the let, is creating a new binding here. It's because here now have is a closure, which hold is a reference to the outs. In this case, is holding reference, right? Now we can safely say that. So because this loop is using let declaration, each iteration gets new block scope, aka local, index and bottom variable. So when you do this, it's like you're creating inside of here is per each iteration a new instance of the index and the bottom with that particular value at that moment, right? So this closure is not over the value like in, but over the variable itself. And that's what happened here. So now it makes a lot of sense here when you see things like this. It's holding is a reference to the outside, to the outer scope. So and because, oh my God, and because closure hold is a reference, and because closures holds holds a reference to the outer scope variables, in the way how reference works in JavaScript is like objects assigning. It's like object passing or assigning into a variable, all right, this reference will be there until exactly this reference will be there until a memory leak or the reference being released. How do you release this reference here in a closure? How do you release this reference in a closure? Because you have now this reference in that definition time, it creates that. One way is to, when you call that particular function, you get rid of that. All right. How do you release this reference in a closure? So you are, great question. You're absolutely right that closure hold reference to a variable in their outer scope, but it holds the reference, and this reference persists as long as a closure exists. And here's how reference get released. Automatic release most common. So one way to do that is say large array you are creating is a closure that has a reference to the outer scope, and because it has a reference, as long as that is at this point, data is still referenced by my closure. So you are creating is a closure here. So now the closure is unreachable. Garbage collector can now clean up both the closure and the data. Manual release pattern. Nullify reference within the closure. So, okay, nullify reference within the closures. Exactly. So let me use that, and then now let me clean up here. Weak map for automatic cleanup. So it makes much more sense to define out this weak reference here for that, right? So for example, here when you create this closure, you say, hey, private data here. Okay, weak map. Weak map doesn't prevent garbage collection. So you create now the closure here with the heavy data. All right. And object is equal to null. Both the objects and heavy data can be garbage collected. Event listener cleanup. Because when you're adding this, you say cleanup later, button remove event listener, and click handler. And heavy data is equal to null. Optional explicit cleanup. Const cleanup setup listener later. Cleanup release a closure and it is reference. Key point automatic garbage collection. Most of the time, just removing reference to the closure itself is enough. Circular reference. Modern JavaScript engine handle this well, but be aware in complex scenarios. Event listener. Always remove them to prevent memory leaks. And timers. Click set timeout and set intervals because they held is reference. JavaScript timers. Click set timeout and set intervals because those functions call, if you have now a function, a reference to that, now it's creating is that link, and therefore you need to clear that, but you need to clear is that interval, that ID. Okay, this particular padding is quite clever, by the way, quite clever. if you define this as a function, hey, I'm returning is this, and then the cleanup function explicitly release the reference. So okay, that's very, very, very interesting when it comes to closures. All right, when it comes to closures, and it's because it's whole is a reference to that. Mm-hmm. Closure is one of the most prevalent and important programming pattern in any language, but that is specifically true to JavaScript. It is hard to imagine doing anything useful without leveraging closure in one way or another. If you're still feeling unclear or sharky about closure, the majority of the book 2 scope closure is focused on this topic. Okay. Alright. Okay. Makes sense. So, yeah. Mm-hmm. Mm. Mm-hmm. Okay. Ah, okay. Mm-hmm. Okay, holy hell. So anytime that you create is a function, uh, and that function has a reference to outer variables, all right, whether it's here, or even functions that you define here, all right. So for example, or even nested weird stuff here, or even nested weird stuff like, hey, you have now a functions that somehow it is so you say now reset, all right, and this reset function, what it's gonna do is just to say count to 0, all right. And for some reason, if you say this, exactly. So anytime a function has a reference to the outside scope, all right, you are creating effectively is a closure. But the way how you can release that is by the not only this is the most common way to create a closure, but also you create is a closure inside of objects as well. So object does not closures. But nested function or function callbacks here creating is now a reference to that. Makes a lot of sense. Alright, so that'll be all for this video. Take care. Bye bye.